So I did ask the question, and a lot of you guys answered, so it's time for hell yeah, more modelling. Welcome back to Making for Motorsport, where we make more, spend less and go faster. So back in the Velocity Stacks video, I asked you this. So if you're interested in this and you want to see this video of modelling, then hey, leave a comment saying, hell yeah, more modelling. And by the looks of the comments, quite a few of you guys do. So by popular demand, this is the video, hell yeah, more modelling. So looking at the comments, it appears people fall into one of two camps. Either they don't know where to start and they don't really have any confidence or any knowledge, or people have got an idea but they don't really have the kind of the advanced toolbox to be able to do something a bit trickier like this. So if you want to model something or you've got a particular problem, then put it in the comments. You'll be surprised, people out there will probably be able to give you a clue. So cards on the table, guys. I am not a 3D modeling professional, nor am I a teacher. So this may not be the absolute step-by-step by the numbers method of learning 3D modeling, but that's not how I learned either. This is going to be how I approach 3D modeling, the things that I think are important and which I'd known when I started. And hopefully that can condense what's been a good few years of feeling my way around into one video to give you guys a really good start. So this is going to be a two-part series because it's going to be very difficult in one session to cover off the really simple 1 + 1 = 2 steps to 3D modeling, as well as covering the detail of the more advanced techniques in here, so you guys can do it as well, because I don't want to skip over any of the information for either of those two groups of people we've already mentioned. So this is going to be a long video because there is a lot to cover, but so you guys aren't sitting through something you don't need to know, I'll put all the timestamps and the chapters up here, and I'll put them in the description so they'll all appear on the timeline down here as well. So there's lots of different software packages out there, and a vast sweeping generalization is to say that they fall into generally two camps. One are mesh-based programs, which are more for kind of artistic sculptures and stuff we're not really interested in, to be honest. And then there's parametric, which are numbers-based, engineering-biased programs. So if you're watching this, you'll probably want a parametric-based program, and also you probably want it to be free. So Fusion 360 ticks both those boxes, and it's what I use. So Fusion 360 is made by Autodesk, which is a big beast of kind of the engineering software. It's based on its big brother Inventor. It's got all the features that you need to do all the stuff you've seen on my channel and more. It doesn't have some of the more advanced stuff like CFD and FEA, but quite honestly, you don't need those when you're starting out. They're only going to make life more complicated. So this is intuitive, it's easy to learn, it's what I've learnt on, and you know what? Well, it's free. And if you do find you want to upgrade, then it's not tear your eyeballs out expensive like some of the other ones which are, you know, only really available to large engineering companies and pirates. So I'll put a link in the description where you can download it. The first thing to know about 3D modeling is every 3D object starts with a 2D shape. A cube is a square extended up vertically. You revolve an arc to get a sphere, and a Toblerone is a triangle extended long ways. Triangles, yummy. So let's model something. Let's make a cube. So first off, we need to make a sketch. So we make a sketch, select a plane, and then we get into the drawing space and we start sketching. Well, hang on. I've presumed too much. let's rewind. So, every 3D object starts with a 2D shape, and to draw in 2 dimensions, you need 2 dimensions. That's X and Y. And between the two of those, they make a plane, which is a flat surface, which is essentially infinite. And you can think of that as basically a plain piece of paper that you can draw on. You can draw a shape as long as it's flat. So now to make something 3D, we need a 3rd dimension, and that comes perpendicular out of the plane and is called Z. And by bringing that one extra axis, you get 2 extra planes, XZ and YZ, to go with XY that we already had. So within these 3 dimensions, using the 3 axes, you can define any point in space compared to the origin with 3 numbers, or you can define any path or any shape with a big set of these 3 numbers. And not only that, we can also define new planes if the 3 we already have are in the right position or at the right angle. Right then, so now we've got our 3-dimensional space. Let's draw something. Let's draw a cube. Sounds familiar. Anyway, so we know we've got this 3-dimensional area, and we've got our axes up there, X, Y and Z. And so we're going to draw a cube, we need to start with a square. So we're going to draw a square on X and Y. And then I'm going to use this cube here, which helps control the views. Click on there, and that brings us to a nice perpendicular view. So I'm going to go up there and select 2-point rectangle, and I'm going to click on the origin and drag it out to 30 by 30, and it's nicely snapped to those dimensions. And there you have it. There's our 30 by 30 square, and I'm going to turn the origin off just to make it a bit clearer. So before we go any further, I'm going to take a brief diversion and talk about constraints, because I wish I knew about these from the start. Tricky little things. I'm not going to go into huge detail, but I'm going to introduce the idea of them. So you can see at the moment we've got some black lines and some blue lines. Now the blue lines are unconstrained and the black ones are constrained. So constrained means that the computer logically knows how big they are, either because they've been explicitly dimensioned or they've been geometrically related back to other things that we have that have been dimensioned. So at the moment we've automatically had some constraints popped on. So the here and here you can see relate to this constraint, which is horizontal and vertical, and that means that it's either uppy downy or side to side. Technical terms. So in order to fully constrain this cube, what we're going to do is we're going to dimension it. So we're going to get sketch dimension and we're going to click on that. It's going to come up as 30 because that's already is, and we can just press enter and it's made this line fully constrained, because we know that one's parallel to that one because they're both vertical, and we know the gap between them is 30. Now this isn't constrained because it could still move this direction. So if we constrain that there, again it's going to come out as 30 because it already is. Now we could have put those dimensions on when we drew the square, which is what we will do in the future, but you can do these things afterwards. And now it's black, it's fully constrained. Excellent. So we've got our square. So now let's go and extrude it and make it 3-dimensional. So you can see that's our square. So I'm getting 2-dimensional square. I'll put the origin on so you can see it. So what we're going to do is make that 3-dimensional by bringing it out into the Z axis out here. So we're going to do that using extrude. Now this little pop-up box appears and you've got all types of options, but because we've only got one profile, which is a shape, it automatically selects it. So we can either grab this arrow and pull it out, or we can use the numbers here, but I'm going to drag it out to 30 and click OK, and there you have it. Well done, we've just made our first 3D object, and it's a 30 by 30 by 30 cube. So I've not changed my mind. I don't want it to be 30 by 30 by 30. I want it to be 30 by 60 by 30. So that means I need to go back and change the original sketch. So I could go back and I could delete everything and start again, and that wouldn't be too hard at this point. But because we've put constraints in, we can do it the smart way. So we can go back on the timeline, which is this line down at the bottom here, and it basically allows us to go back. So we double click on the sketch, it will open straight to the sketch that we just did. So if I want this to be 60 in this dimension, I don't need to delete the drawing. I just need to click on that 30 and change it to whatever I want it to be. So I want it to be 60, and that's already changed automatically. Now, as soon as I click finish sketch, the extrusion, this 3D object that's based on that sketch, has also changed because everything's logically stacked on top of each other. Nice and easy. Now, but I don't just want one cuboid. I want two. And I want another one just here, and I want it 30 millimeters away from that one. So let's go and put that in. So if we go to back in the timeline again, we click on the sketch. So I'm just going to draw another rectangle, and I don't care where it is because I'm going to put it all in with constraints. So put it in there, and I know I want it 60 in that dimension and I want it 30 in that dimension. So although we've got the dimensions in now, it's not constrained because we don't know where it relates to this one. So I'm going to put some constraints in. So I'm going to say that this line here must be in line with that, or collinear. So click on collinear, click that line, and click that line because that's constrained. This moves to that. And then I know I said I wanted this line to be 30 millimeters away from this line. So we get the dimension, click that point, and again, pop our number in there. And there you have it. So without actually having to be accurate with my drawings, I've just used the data, the numbers, and now the software knows that logically this box must be this size and must be in line with that, and these lines must be 30 millimeters away from each other. So if we finish the sketch, we can add it to this original extrusion, or we can put another extrusion in, but we'll add it to this one instead of doing a whole new one. So quick newbie error: if you find sketches disappear, you can't see it anymore, you need to go to here. So what the software does is, as soon as you've made a 3D object out of a sketch, it hides it just to tidy up the screen. So we can make it clear again just by clicking on that little eye icon, and I can go into this extrude option, and where it says profile selected, I can just select that profile as well, and it follows the same rules as the first extrusion. Done. I've changed my mind again. Yeah, I know. I don't want this to be 30 by 60 anymore. I want it to be back to being a 30 by 30 by 30 cube. But I want to retain this one as 30 by 60, and I also need to retain that 30 mil gap there. So this is where it gets very powerful, because if I know my key design points are this size plus 30 mil gap plus that, then that's baked into the constraints. So I can go back to the sketch here, and I can just go to that constraint because I know that this position is predicated on this gap plus that length, because that's how it's constrained. If I put that to 30, everything moves up because it's baked in logically. And as soon as I click finish sketch, I bet you can guess what happens next. The 3D model just follows along automatically. Now, a word of caution with constraints: do not over constrain. The software won't let you over constrain, but only use them when it is absolutely critical. We're not doing things that are that complicated that we must have everything 100% constrained. If you're struggling to get something constrained easily, then okay, fine, move on, maybe come back to it, but don't obsess over it, because with lots of the stuff we're doing, it's just not worth the hassle, especially when we're not going to be going back and revisiting designs time after time to tweak them. We might get them pretty much straight right first out the box. So they're the absolute basics. So I think we'll learn the rest of the techniques doing some 3D modeling. So now we know the basics, let's model something from scratch. And let's do what started this whole thing off, the velocity stacks. So as we've said before, we're going to need a sketch. We're going to need to start somewhere. So let's start on X, Y, and let's draw the base plate. So I know for sure I've got a drawing, and I've got a drawing kind of over there. So I know my key dimensions, and my first key dimension are the induction holes, which are 45 millimeters in diameter, and they are 80 millimeters apart. So 45 again in diameter. Now I'm going to constrain these and put some effort into constraining them because they are important to me. So I can just put that there and say they are 80 millimeters apart, but I need to constrain it in this direction. So what I'm going to do is simply make an imaginary line, which we call construction lines. You see it's all dotted, but imaginary construction line along X. And I'm going to say that the center of this drawing is collinear to this. See, what I'll do is I'll call that, I'll make this 80, and I shall say that that is coincident to that point there. Job's a good one. And then actually, I don't need that point because this construction line does it all for me. See, I don't know everything. You've got to kind of feel it out as you go. Right then, so that's the first point that's important. Then we need the bolt holes. So we're going to make these are going to be 6mm diameter holes, and I know I need them around here and here, so I'm just going to draw them in to start with, and there you go. Now what I would like is a center line here between these two, and I can do that again with just another construction line, and we can put it there. I make sure it's horizontal, it's constrained there. And let's also, for reasons you'll see later, let's make it 13 millimeters long, because that's the height I need this off. And then let's also make it 40 millimeters from the edge there, because that's the center between these 2 points. Then that means I can make that coincident to there. So that's now all constrained. And these 2 points, I could use the mirror function, the symmetry function, but I'm just going to constrain them the old-fashioned way because that's the bit that's most familiar. So it's just naturally the quickest. So I know they want to be 126 millimeters apart from each other, and they want to be symmetrical to that point. So I can just throw that one on there, and 63. So that now means that they are all, if they're 126 and that's 63, that means that must be 63, so I don't need to dimension that. And then I need to just give these a vertical location. So from there back to there, I know they want to be 34. And the same goes for that one, 34. And they're my key points. So I'm not going to get really hung up about the base plate. In fact, just to keep it really simple for you guys, you can make it look all pretty and offset and do all that, but what we're going to do for the moment is we're just going to draw ourselves, not in construction, we're just going to draw a nice big square around it, and I'm just going to space it on these axes so it's nice and even. And there you have it. This could be our finished base plate. So if you ever have something strange happen, like you click that and everything disappears, make sure you come over here, because of work I was doing on this before I started filming, I've got sketches turned off. So if I click them back on, that immediately comes to life. So what I've got here is a nice constrained, fully constrained sketch, because everything's nice and black. So what I can do is I can just extrude this space, and I can extrude it. I'll just get this like that, offset, so you can see me when I extrude it. Again, it's all laid out. We're going to extrude it up 10 mil. Now it looks a bit ugly at the moment with all these sharp edges, so I can go in and give it a fillet on each of these corners of, well, let's have a look, see what looks right. Yeah, that looks about right. 5 mil fillets. And there you have it. There's our base plate with all the critical bits of information on there. But again, I've forgotten one thing, and that is I need a space here for the idle air jets. So if I go back in, and I can just create a bit of a rectangle here. So let's just call it that. What we might do is make this, so you can see, is that looks like it might work, but it's a little bit, so it looks good at the moment, but it's going into the walls of these. So I'm just gonna push these out, let's say 8 mil. 8 mil, and that gives me a closed area there with an 8 mil gap to the middle of the trumpet. So it hasn't changed on here, so I can just go back to the selection and I can unselect that, and you can see now we've got that gap. So really that's the beauty of being able to use the timeline. You can kind of go forwards and backwards without having to unpick all your work. So right, that really is our finished base plate now. So that's good, everything's in the right place, it's fully constrained, so we can use that to build on. So what do we need to do now? We need to build the actual stack itself. We need to make it out in the Z direction, which is the blue axis. So we need to draw along the Z axis. So we need one of these axes. I'm going to pick this one. So we'll create a sketch, and we'll pick the YZ axis, and there you go. We'll go perpendicular. Now I know my whole inlet track there is based off the origin, so we don't need this body here, the base plate, getting in the way, so we'll take that off. Now I want all these dimensions fully constrained, and a really good way of doing that is to make sure you've got it fully constrained, is to draw it off in space and then bring it into where you want it, be it a circle or a line or whatever, using constraints. So that just means you know you're constraining it in the right place. So I'm making it 110 millimeters long. I know it wants to be 22.5 because my diameter is 45, so this is the radius, and I want it to start on this axis here. So I'm going to use the coincident, bring that point there in line with this point, and there you have it. So if we flash the body back on, let's make sure we're somewhere right, and we'll just drag it through. Yep, that looks pretty good to me. Oh, there we go, and we'll turn the body back off again. So I know I've got 80 mil between, so I've got a radius of 40 is my maximum diameter for the flare on the end. So I know I've got 22.5, so I've got 17.5 mil to play with. So I want to get a gap, so I'm going to make it 15 mil, the extra space going off here, the extents that we've got. So we'll click there. No, remember I said draw it off into space, so 15 mil, and then we're going to constrain that, bring it into the edge there. Nope. I can coincident that to there, and you can see it's turned black. So we've used the origin, we've gone up to that point, 22.5 mil, we've gone out 110, and we're there for 15. So what we've got now are the length and the extent of the diameter of the flare and our diameter. So what we need then is the wall thickness. So we can do that very easily with the offset tool and bring ourselves a 3mm wall just by offsetting that dimension. So we know, again, it's all constrained because it's coming from constrained features. Now what we need here is a radius here. So really we want a circle. So I think the best way of doing that will be by using a part of a circle. So we're going to use a 15mm, a 30mm diameter circle, because that portion there, that quadrant of the circumference, will give us a nice curve there. So what we need to do is to bring that in to the right position. So I think if we create a construction line coming off here, 15mm, again, because it's coming off constraints, we know where it is, and then we can simply put this constraint to there, and now we have a nice continuous line that we can pick up that goes out to our point there. Now what we need to have is something to close that, to make this a continuous shape. Now if I start deleting these things, so if I delete that line now, because that forms part of the train of constraining all this becomes unconstrained. So I'm going to leave all these lines in. If I want to, I can make them construction lines, make myself feel a little better, but you know what, there's no need to, as long as you can see through it. What I do need to do is close this. So what I'm going to make is a return line from here to probably that point there. Make that not a construction line. So why have I made this a straight line, not a curve? Because as this will be printed, it will be in this direction, and this line here will be an overhang. So you've got to be careful of overhangs in 3D printing. So you might be struggling to see how this turns into the profile. Well, we've got to do one thing first. See how this is slightly blue. That tells you it's an enclosed area that you could make into a profile, you could extrude, but this isn't, because we've got a gap here. So we'll just create a nice little line. Again, because we're picking up on defined points on constrained sketch, that is also constrained. We'll make that not a construction line, but an actual part line. And you can see now everything's blue. So we can pick any parts of these to extrude. So let's do that. So we bring the body back in. So we're not going to extrude this. We're going to revolve it. So what that means is we're going to pick certain points, certain profiles, and then we've got an axis there, the Z axis, which is in the center, remember, of our inlet tract, and we are going to revolve this around that center line. And let me show you. So again, we click revolve, the pop-up box tells us where we need to do. We need to select the profile, so we're going to click that one, and that one. We need to select the axis to revolve it around. And we're going to click this one. Straight away, look at that. We've got something popping out to greet us. Now it's red because it's set as a cut at the moment. Now, I don't want it, normally you'd kind of select that as a joint. So this is a cut because you're intersecting with an existing body. If you build on another body, that's usually a join. But I'll show you why later, but we're going to create a new body here. And you see, as soon as we do that, it stops being red and it goes to like the part color. So that looks pretty good. So had a look around it, we'll click OK, and there we have it. So it's probably a little on the bulbous side, but I'm not too fussed about that. Let's finish the job. So we need another one for here. And the reason I made it a new part, a new body, is because that means I can copy it and I can move it without having to copy the base plate. So I come here, go to copy again, little pop-up box, we're moving bodies. We can select this body. Now, there's lots of different moving options, point to point, la la la. I'm going to use translate because I know exactly the number, the distance I need to move it, and the axis I need to move it in, which is X, and I need to move it 80 because that's the gap between the inlet tracks. There you go, it's moved completely. I'm going to click copy because I want it to copy, and there you have it. See, that looks pretty good. Let's just have a quick look at what it looks like for the as a cross section, because it's a bit deceptive. So we can use the section analysis tool, which is really useful, and it slices the part down on a plane that you select. So we can select a plane. I used to like select a face of the part, and see, we get a new like cutting plane that comes up, and we can see here that it might not look it particularly, but you can see we've got a lovely smooth kind of quarter circular radius coming into the velocity stack. Excellent. Now let's turn that off. You go to the analysis section there. Now the reason why I wanted all of that geometry fully constrained is because if I want to go and change the length, I can do. So I don't want them 110 mil. I want them a different length. And because everything got constrained coming out on that first length, if I change this, let's say to 60, it all just comes back in because it's all built logically off that first route out. And there you have it. So now we've got some 60 mil velocity stacks. If I want that to be 160 mil, well, you just go in, change it one more time. And because we built this side directly from that side, as soon as you change that side, it follows it through and it relives the timeline. So it makes changing things really, really easy. So we've got two more things left to do to this model. I want to have a brace between these two because they're now 160 mil long. They're going to flap about all over the place. Let's put a brace in. And I'm also going to use that brace to mount a sensor. So I want it to be flat in the same plane as the base plate, so the sensor's sticking up. So we need to draw a profile here that we can then extrude, but we haven't got anything to draw it on. We haven't got a surface or a plane. So we need to make one. So what we can do is we can use one of these, either a planar surface like that, or a plane to create an offset plane. So we can click offset plane, and then we can select the plane we want. So we can use that surface there, which we could also draw on if we wanted to, but we can select that surface and we can drag off to there. So let's say it's 70 mil now above that surface. If we change the thickness of that earlier in the model, then that will change the height of this plane because it will stay 70 mil off there. So you've just got to be aware of what you're basing it. Again, it's just logical steps one by one. So we've now got a plane floating in air there, and we can draw on that. So if we go to draw, and we've now got a plane, if you can see that it kind of cuts through about halfway up pretty much. So let's go perpendicular on our view again, and let's turn off the bodies so we can see it. But what I want to do is turn the sketches back on. So you can see here that we've still got the drawing, because I turned it back on, the original sketch. So I don't want to have to redraw all this stuff and redraw everything in place. I've already got it there. It's just not on the right plane for me. My plane is up the Z-axis. So what I can do is I can use the project function to project that drawing onto my new plane along that axis, the other axis. So we go to create, we go to project, and we can select the drawings that we want to pull through. So we could just select all of it, to be fair, but I'm going to pull through everything that's around here, which was to do with the hole we originally did in the base plate. So if I click OK to all those, then you can see that those lines have been projected onto my drawing plane that I'm on at the moment from the original sketch that I did. And that's good because I've now got in there the geometry that I really want. So I'm going to click OK, and then we're going to put the bodies back on. So you can see here I've got this drawing floating in the air halfway up my velocity stack. So if I now extrude the profiles that I want, so I want that one and these two here, and let's make it 3mm. Haha, spot the deliberate mistake. So what did I do wrong there? I got it wrong because I didn't think about it. Because I'm intersecting with an existing body, it's defaulted to cut. So if I put in, again, new body, like we did last time, click there, and you can see now we've got ourselves a brace. It's a bit ugly because we've got these sections sticking out here. So what we can do is we can just use the chamfer tool. I could go in and change that drawing, but just for expediency, I can go in and just make these make both of these the same, just to tidy it up a little bit. Really, I'd change the drawing, but I think what I want to do is just get through this model, and you can see how you spend a lot of time tweaking and changing and making things absolutely perfect. Anyway, so we'll turn all the sketches off now because we're done with those. Now what I want to do is I want to go back to the cross-sectional analysis, and you can see here we've got lots and lots of height now, and we've got a nice sharp right angle there, which is going to cause us some big stress raises. So what I want to do is put in some big chamfers here, so I'm going to go to the chamfer tool, and I'm trying to select this outside edge here where these two join, but I can't do it because at the moment all these parts are individual. They're separate bodies. So we've got 4 different bodies that make up the 2 stacks, the base plate, and the brace. So I need to combine these. So I'm going to click on the combine tool. I'm going to use and combine everything into the base plate. So target is the base plate. The tools, because this is a combine, you're going to combine with the other one. So I'm going to click this, this, and that. That's everything clicked. If I want to make a new component, I could, but no, I'm going to just keep it all in one. And there you have it. So now we've got one body that is the whole thing. So now maybe we can use the chamfer tool, and you can see now we can select that corner there. So we'll select that one and that one, and we can pull it out and do a bit of a chamfer like this. We shouldn't have that face selected, so let's try again, David. And you can see as soon as we get to any decent size chamfer, we start interfering with the base plate, which I don't like. So we'll make it an unequal distance, so 2 distances. Have this bottom section 5mm, or is that? That's the horizontal, that's the vertical section. So we'll make that 5. And we can pull that up to maybe 30. You see there we've got that little section there which I don't really like, so we'll make it 4mm, and that's pulled it in. And there you have it. So now we've got a nice big chamfer on the bottom. I click OK to that, and there you go. So we'll go back to the analysis, we'll turn that back on, and you can see now we've got a much thicker route there to the velocity stacks themselves, so that should be a lot sturdier. So we'll turn that off, and there you have it. That's the finished velocity stack. So even at this late stage, if I now decide I don't want it to be 160mm long, that's the wrong sketch, I can go back to the sketch for the stacks themselves, and I can make them back to 110 and click OK. And you can see, there we have it. We're back at our original length. The brace hasn't moved because it's not, I've not changed it not changed the height to that piece there, but it doesn't matter. I could change that if I wanted to, but there you go. So that is one part completely modeled from start to finish. Okay guys, if you're still watching now, give yourself a massive pat on the back because that was a bit of a marathon. But then straight away, hit the thumbs up button, please. It really does help. If you'd like to support the channel in a more direct way, then head over to the Patreon page. I've got lots of Patreon-only content. You get early access to videos and Discord service, all the normal perks. And best of all, you get your name down there at the bottom of the video, which these guys already have done. So thank you very much to them, because every penny I get through the Patreon will end up on the screen here as more projects in the future. So it really will help push the channel forward. So if you like this one, then hit subscribe so you don't miss the second installment, which is coming soon. And I will put it there when it's out. Until then, catch you later. Ooh, ah.